How to learn Python or any programming language. I like to talk about this topic early in the class and give you a complete roadmap on what it takes to actually learn Python, right? Like you're sitting around, if you don't have any programming experience especially, and you may ask yourself, what is it that I actually need to know before I can say, hey, I know how to program in Python. Now, you're not going to be great. You may not be proficient, but at least you'll have a foundation. And so that's what this brief lecture is all about, is to kind of present that roadmap of what it takes to learn Python. So you know if you're on the right track and to put you on the right track. So programming in Python isn't hard, right? Programming in any programming language isn't hard. Programming in Python is hard. And that is, if you're not an experienced programmer, then you're not only learning Python, you're learning how to program in Python. Okay. And programming is challenging, is mentally challenging, right? If you're not a programmer, there's ways of thinking, there's ways of approaching problems, there's problem solving techniques, there's problem decomposition. Then there's, how do you approach a problem? How do you get unstuck? That kind of, there's just so much to programming that after you've done it for a while, it becomes second nature after you learn it. But it's that all these different inputs that you receive during your education and during your, early career, or just doing it. You may not even be employed as a programmer, but if you program, then eventually you'll learn this set of techniques that is called programming. And then, of course, programming, the art of programming, which is one way to describe it, it can be applied to any programming language, right? Once you learn how to program, then picking up a new language is a matter of picking up a new language, right? You don't necessarily have to go to school for that new language, okay? So just keep that in mind, right? Especially if you're new and you're a novice. And in this particular class, which I'm creating this video for my IT-566 students, which is Introduction to Computer Scripting Techniques. It's a graduate class, but there's no assumption that you have any programming experience, right? Which is kind of an interesting graduate class. So hard isn't really the right word, but you'll spend way more time learning to program versus learning Python. Python is a relatively easy language to master, right? It's the programming part, how do I employ a for loop? When do I need a for loop, right? And, once you figure out when you need to do those types of things, then employing them in Python is quite frankly pretty simple, right? Which is why Python's a very popular language, okay? So, like I said, if you're new to programming, you're learning two new concepts: how to program and Python. That's hard. Once you learn how to program, learning another programming language is easy, okay? But there are caveats. First, it depends on the first programming language. If you are a practicing programmer, or if you have learned to program in the past, in school or otherwise, how easy it is for you to pick up Python kind of depends on your first programming language. And by that I mean, if you know how to program in C, C++, C#, and Java, those languages require line endings at the end of each statement, like a semicolon, right? That's not required in Python, so there's some habits you got to break. For loops, you can employ a counter, right? The way that you write for loops, everything is based on an iterator in Python, so that's a difference there, right? So there's all these different Pythonic things that if you are already a seasoned programmer, you're gonna be scratching your head, right? And what type of programming paradigm? Was it object-oriented? Was it functional, right? How you learn how to design and implement your programs. And by paradigm, I mean imperative versus declarative. Okay. And imperative programming is like machine code, assembly, procedural languages. Most every language you learn, unless it's functional programming languages like F# or Lisp or Scheme, right? Most every language that you use is an imperative language. In other words, you put one statement after the other, right? A declarative language usually is a functional programming language. You declare what your intentions are versus instructing step by step by step, okay? Anyway, and then Python supports paradigms to certain degrees, right? So imperative, but like I say, Python supports multiple paradigms to certain degrees. Python supports the imperative paradigm, the imperative object-oriented, and functional programming to a large degree, okay? And we get more into these types of paradigms as the semester progresses. So now, how to learn Python, or how to learn just about any programming language, but Python specifically, right? If you print any page in this presentation, this is the one you should print. So I'm going to start in the upper left-hand corner. First, how do you find answers, right? Because especially if you're new to Python, you're going to want to find answers to your questions. You're going to have a lot of questions. And the going may be painfully slow, right? So learn how to find answers. Python documents, Google, and YouTube. And I think what you'll find is the Python docs, some of them are good, like the introduction to Python programming, but the docs themselves can be rather thick or hard to decipher if you're a novice programmer, right? So Google is your friend, but we're going to talk about Google Dorks in this class. And in my chapter 6 in my book, Computer Scripting Techniques with Python, that chapter is all dedicated about how to get help. So I recommend you take a review of that chapter. Okay, so finding answers is important. And notice that finding answers to your questions is like the number one thing that you need to master in order to learn how to program in not just Python, but any language, right? Organize your code. You need to know how to organize your code. A lot of people, when they just start off, they just throw their Python files on their desktop. They throw them willy-nilly, and then they forget where they're at, and then they forget which project they're working on, and then they'll spend hours editing something, and they try running a different file. I've seen it. So you need to figure out how to get organized, and you don't have to do this on your own. I provide a whole chapter on how to organize your projects, right? And it starts usually, well, in all cases in my class, with creating a dev folder in your home directory. Okay, so I talk a lot about how to get organized and stay organized. And you got to get organized and stay organized up front. You know, you don't put organization on a project as a bolt-on later on. And organization is not just about a physical, like where you put your code, but how to organize your code into packages and modules and functions and classes. Okay, so you know, once you know how to organize your code, then you know you're taking the right step. Okay, how to create code, like what IDE you use. In this class, we use Visual Studio Code. You can use other IDEs, but I recommend Visual Studio Code. It's easy to learn. It only takes 2 plugins to do Python programming, and it's wonderful, right? It's a great integrated development environment. How to format your code. Python is really persnickety, right? When it comes to like tabs versus spaces and how to align the function definitions or method definitions, and then the code that belongs to the method, and then if statement, and then the code that belongs in the body of the if statement, or the else clause, or the ELF clause, right? So everything in Python, all the code, the source code is lined up, and it's not just randomly lined up. And this is a big habit that you got to break, especially if you come from different programming languages. So how to format your code. And there's a whole PEP a reference document called PEP 8, right? Which tells you how to format your code, how to name your variables, how to name your functions. So don't just do things willy-nilly. And I'll be showing you this stuff as the semester progresses, okay? How to run your programs. Once you have a Python source file, how do you run it, right? There's different ways to run your programs. You can run a Python program in the REPL. We don't do that very often, only show you how to do it on the first day of class or the second day of class. The REPL is a great way to experiment with little small snippets of code, but other than that, you're mostly going to be just running a file from the command line. And then, very important, how to debug your program. Like, you are going to make mistakes. You're going to make typos. You're going to make logical errors. You're going to need to know how to fix your code, right? And then how to test code, how to create unit tests, okay? How to name things, how to name variables, how to name functions. Again, this goes back to not only PEP 8, but beyond PEP 8 is your problem domain plays a lot in how you name things. But most importantly, there's a format defined in PEP 8 for naming your modules, and then naming classes, and then naming functions, and signaling your intention using an underscore to start the name of a variable or a function. Those types of things you'll learn throughout the course of the semester, okay? Scoping rules. Scoping rules as they apply to global variables, local variables within methods and functions. Scoping rules as they apply to parameters within a method or a function. Okay, operators, like logical comparison operators, membership operators, that type of stuff. Okay, branch or looping, like how do you loop? Okay, you need to be able to control the flow of execution in your programs. So Python provides a for and a while loop. All right. How to do branching, how to make your code select alternative paths of execution. If else and if elif else match, okay, statements, match case. And then data structures, how to use tuples, lists, dictionaries, and sets. You need to know a handful at least of Python's built-in functions. These include the print, the str, the int, the float. I mean, there's a handful of them, and we go over those starting from day one in class. How to provide data input and output to your programs. Okay. How to do file processing, how to handle exceptions, how to install and use third-party libraries. And most importantly, especially if you come from a different programming language background, how to break old habits, because there's the Pythonic way of doing things. And you can tell a person who's come from, like, let's say Java, and they try to write a for statement in a Java fashion, that, it just looks clunky, right? There is a Pythonic way of doing things. And once you learn the Python way, when you're programming in Python. Now, once you go from, let's say, if you learn Python first, then you're going to find moving to these other different languages challenging from a syntax standpoint, right? Because Python's not like C or C++. Python's its own little thing. Python, its own world, right? But this slide right here, number 28 in this slide deck, print this out, write these things down, and if you know each of these things with any minimal level of competency, then you can say that you've got a decent foundation in Python programming. It's not everything that you need to know, and it's certainly not everything that you're going to learn in this class. It's everything plus. There's more to it. This is just a subset of some of the stuff you're going to learn in this class, is what I'm trying to say. But this subset of things, this set of concepts and skills that you learn that are listed on this slide will enable you to go from this class and attempt to teach yourself more Python, once you finish this semester. Okay. And that's it for this. So we will be talking about every one of these in more detail as the semester progresses. I just wanted to give you a broad overview of what how you can learn Python or any programming language.